Continuing Chapter 1, Equations and Inequalities, we're on Section 1.2 now on quadratic equations. A quadratic equation is an equation equivalent to one in the form ax squared plus bx plus c equals 0, where a, b, and c are real numbers and a cannot be 0. We saw that before in the linear. Again, now a can't be 0 because we lose that x squared term if it is, and we need that for a quadratic equation. This is a second degree equation because the highest power on x is 2. So I just answered that question. Why does the definition say a can't be 0? Because then this term goes away, and then what type of equation would result if that term went away? Well, we'd have bx plus c equals 0, or just some number times x plus c. It's a first degree equation, so it would be what we saw last time, linear equation, or another word for that is first degree. That's what we would have if the first term went to 0. A quadratic equation written in this form, where we start with that highest power and then the next power and down to the constant, is said to be in standard form. There's several ways we can solve quadratic equations: factoring, if it's factorable, the square root method, completing the square, and the quadratic formula. The next few examples will introduce these methods. When a quadratic equation is written in standard form, like this, it may be possible to factor the expression on the left side into the product of two first-degree polynomials and then use the zero product property to solve. Well, those are fancy words. All that means is, and you know this, if a times b equals 0, then a equals 0 or b equals 0. If you multiply two numbers and you get 0, at least one of them has to be 0. That's the zero product property. Product meaning multiplication. All right, so let's see about this. Let's see how we would solve the quadratic equation by factoring. And you do need to know all of these methods and be able to demonstrate all of these methods. Okay. So we learned about factoring a trinomial like this in R.5. We're looking for two integers that multiply to negative 15 but add to positive 2, and turns out that's x plus 5 times x minus 3. Now it equals 0. We're not just factoring, but it's an equation. It was in standard form to begin with, so we're going to factor the left side to the product of two first-degree polynomials, x to the first, and now we'll say if a times b equals 0, then either a equals 0 or b equals 0, and we'll solve these two. Minus 5 on both sides, x equals negative 5, plus 3 on both sides, x equals 3. So there were two solutions. Negative 5, 3 in my curly brackets that indicate a solution. The order, of course, doesn't matter. This is a list notation, type notation, where we just list them and the order doesn't matter. Okay, so we found two solutions to that one. And 2 is the most we could ever find. Okay, let's look at this one. X squared minus 8x plus 16 equals 0. It's in standard form. It's a trinomial. We learned how to factor in R5. We're looking for two integers that multiply to positive 16 and add to negative 8. What are they? They've got to be both negative. When you multiply, you get a positive. When you add, you get a negative. Well, they're both negative 4, aren't they? So do we need to write x minus 4 equals 0, x minus 4 equals 0? No, just once. It's silly to do it more than once. Why did we just get one solution? X is 4, curly brackets 4. Well, this is what we call a double root. It occurs twice. Might make a little note, double root. Another name we'll learn in Chapter 5. We won't need this right now, but it's called a root with a multiplicity of 2 because it occurs twice. Okay, so we found that quadratics can have two solutions. They can also have one if it's a double root. Okay, C. Now this is not a trinomial, but we also learned how to factor a polynomial like this. We looked for the what? The GCF. So let's pull out, since it's already equal to 0, we're good to go. What's the GCF? 3 and 18 share a 3, x squared and x share an x, and that leaves behind x minus 6. So we have 3, notice this is 3 times x minus 6. So I actually don't have a variable for the 3. I could write 3x equals 0, yes. But what does the 3 do? It doesn't do anything, right? So the 3 is an integer. It's not a variable. So really what I'm saying here is either x is 0 or x minus 6 is 0. Yeah, if you wrote 3x equals 0, divide both sides by 3, you'll still get this. But it's unnecessary because, of course, the 3 isn't contributing to this, to the 0 part, right? It's a factor. Okay, so add 6, x equals 6, so we found 2 solutions this time, 0 and 6. You can always check. Very smart to do that. Go back and plug in both answers or the one answer and check. Okay, finally in D, we have a trinomial. There are 3 terms, but it is not in our standard form, 0 on one side. So the first thing we have to do is subtract 3 from both sides. 2x squared minus 5x minus 3 equals 0. Okay, this is one of those where the x squared coefficient is something other than 1. Now, this one's probably not too hard to factor by trial and check. You can also do factor by grouping if you like, but to get a 2, the only way to get 2 is the only factors of 2 are 2 and 1. So there's a 2x in one of them and an x in the other one. The only way to get a negative 3 is 1 and negative 3 or negative 1 and 3, and then I just have to figure out where they go. And you play around with it for a minute. It's probably the easiest thing to do. And what do we get? Maybe put the 3 here and the 1 here, because 3 times 2 would be 6. And there's 1, and I need a difference of 6 and 1 to get 5. I need the 6 to be negative 6, positive 1. So I just kind of played with it a minute. There's my A, there's my B. Either A equals 0 or B equals 0. Subtract 1, 2x equals negative 1. Divide by 2, and x equals negative 1/2. Add 3, x equals 3. 2 solutions, negative 1/2 and 3.